Saxon Algebra 2, Lesson 24. Just to give you guys a little perspective, not that any of this matters, but I know that you are sitting together on Wednesday around noon watching these videos at school, at Westgate. Just for perspective, I typically am recording them, now that I have my fabulous circle light, my ring light, I record them on Tuesday nights. I usually start around 10 or 10:30, and I record each class in order. So first I do Algebra 1/2, then Algebra 1, then 2, and then the Advanced Mathematics kids last. So by the time I get to you, it's usually around midnight, 12:30. My brain is in its prime. This is when I think the best. Then I get everybody recorded, and then I upload and send you links at like 3 in the morning. So just so you know where this is coming from, we're all on the same page. Okay, and I also always do the 2 lessons back to back that you watch together. So I just finished 23, and now I'm ready to do 24, and then you watch them back to back. Oh my gosh, we're so in sync. And I feel like a Backstreet Boy for saying that, but you know what I mean. Okay, example 24.1. This lesson, by the way, has 2 topics. Fractional equations is the algebraic piece, and then we have a little bit of geometry as a follow-on. John often does that in this book. He hits us with a big algebra topic and then teases us with just a little geometry at the end. It's kind of like dessert, you know? Okay, solve. Are you ready? This is what I don't want you to write down in your homework, but I'm going to write it here. 4.5x minus 3/5 equals minus 1 1/4. I hope you know what I'm thinking. I hope you know that I'm thinking, mixed numbers, are you a sick joke, John? I refuse. So the very first thing that we do before you even copy it into your book is go to improper fractions. I don't even want you to write it down like this. That's just disgusting. You can change them in your head as you copy the problem. I wrote it down just so you could see it. Okay, 2 times 4 is 8, plus 1 is 9/2 x, minus 3/5 equals minus 4 times 1 is 4, plus 1 is 5. All right, so we do that from the get-go. We do not traffic in mixed numbers anymore. Good Lord. Okay. The next thing we notice is that there are fractions in this. No, we're not having this. So we're going to blow up the denominators. That is how I always think of it, you guys. I know that's vaguely violent, but that's how fractions make me feel. We want to blow them up. What we need to do that is the least common multiple. 2, 5, and 4. Okay, I know that 2 goes into 4. So if I can make the 4 happy, I will make the 2 happy. 4 and 5, the first number that's going to work for them is 20. So our least common multiple is 20. What I do, because this is an equation, my strategy for blowing up the denominators is different than if it's just an expression with no equal sign. I multiply each term by the LCM. Okay, that's all part of blowing up the denominator. So this is all one big step. Multiply each term on both sides by the LCM. What that's going to let us do is cancel. And because we chose our LCM wisely, every denominator is going to divide cleanly into that LCM. That is a chef's kiss, you guys. That is a mathematician's kiss. And it's going to be beautiful and perfect, and we're going to be so happy. So here's the way. I'm going to use a different color just to help you see it. This is what I'm doing. I'm multiplying each term by the LCM, and I write it like this. I write it up and at an angle. I think you've seen me do this before, because that makes it a lot easier to see what the heck I'm doing. If you want to put a dot there, you could put parentheses around it too, although that just kind of makes me crazy. And then now what we do is when we multiply, we cancel the denominators against this and then multiply what's left against that. So this will cancel and I'll get 10. 5 goes into 24 times, so it'll be like that. And then 4 goes into 25 times. All right, so I'm canceling against the LCM, and whatever remains up top, that's what I'm going to have to multiply that number by in the next step. You could do it in one step, but I'm trying to help you see it all. All right, so now those are gone, and we have 90x minus 12 equals minus 25. Oh, are you happy? I'm thrilled. I think that is beyond adorable, this, right? So much better. So now all we have to do is add 12 to both sides, because there's our x, right? I'm teaching the younger classes how to just do basic equations again. So I'm always like, now you have to find the x and you have to figure out how to isolate it. I don't think I have to go that slow for you guys. But, you know, sometimes it's fun. We Hannah Cranny the heck out of that pup. This is minus 13. Divide by 90. And this is our final answer. I know that 13 is prime, and I know that 90 is not a multiple of 13. So I'm pretty confident that that is least common, and it is. I just looked. Okay? So what we're reviewing here is how to blow up denominators. All right, let's do another one. I think I need a fresh page. These problems are messy. All right, this one is a titch more complex, though thankfully it doesn't have any mixed numbers, so I don't have to rant about that. This is what's crazy about this one. 4x plus 2 over 5. What? It's a binomial. You guys, I'm watching a really good series on Netflix. It's called The Queen's Gambit. It is a story. It's a limited series. I think there's like 7 episodes that are an hour long. It is a Netflix original. It is about a woman who is a chess prodigy. So technically it's not about math, but she has a super mathy analytical brain. And it starts in her childhood and shows what she went through as she was like unlocking this incredible gift of chess wizardry. And it shows her in her high school math class, and the teacher asks, "What's a binomial?" And she said it's an algebraic expression of 2 terms. And I was like, go Beth. Beth Harmon is her name. So anyway, it's a really good movie. It is very teenager friendly, at least so far. There's no, well, I mean, technically there's drugs, but that's not her fault. It was the orphanage where she lived was giving her tranquilizers. But, oh, it's Gambit, sorry. But if you're at all interested in a really cool movie about a girl, she kind of is like, I mean, she's super brilliant, but she's one of those people, like she sort of has like Asperger's or something where her social skills are maybe a little off, but she's an amazing chess whiz. So check it out. I highly recommend. So there's the binomial. That's what started me on the whole thing. This one now has a binomial in it. Our process, though, is exactly the same. We find the LCM, 5, 2, and 3. All right, well, none of those guys are friends. So I'm thinking that the first thing they're all going to go into is 30. And I got that by multiplying them all together because they're all prime numbers. So there's nothing that's going to combine any simpler. So I go to multiply by each term by the LCM. Now, when I see this binomial, I'm going to do that because I have to multiply whatever I am doing here. I have to do to this as a unit. So there's my 30s. Now I do the same thing. This is going to cancel and give me 6, and I'm going to multiply the 6 times that in the next step. 30 and 2, that gives me 15, and it's 15 times 1, so I can just write the 15. That'll be easier. And then the same thing here, 30 and 3, that's 10, and that's a 1, so I'll just make that a 10. I'm essentially multiplying in one step. Except I see a mistake I made. I made a mistake in writing down the problem. This is a 3. So 30, 10 is 15. So this is 3 times 15. The 15 is the 30 over the 2, and the 3 is the number that should have been there in the first place. I thought it was a 1, but there's only a 1 here. This is a 3. Okay, my bad. Once again, you guys, that is my biggest drama, is copying down the problem wrong. And if it happens to me all the time, it's possible that it's happening to some of my students too. It's kind of a human error thing. So I get so excited by the problem that I just like copy wrong. All right. But anyway, we're fine now. Now, when we go to do these multiplications, here with the binomial, this is the tricky part. I have to remember to distribute. So we're going to get 24x plus 12 minus 45 equals 10. Sound good? Okay. I like it so far. Now what we can do is write these together. This will be 24x minus 33. Yes. Equals 10. And then we'll add 33 to both sides because we're isolating that little x dude. That X-man, you might say. 24x equals 43. And we're going to divide by 24. Now, 24 has a ton of factors, but 43 is prime. So, it's not going to simplify. I just rewrite the x over here so that my answer is neat and concise. But I don't want to copy that over because I'm just introducing the potential for risk. Okay, that's 24.2. Let me flip one more time. Goodbye, Queen's Gambit. It's really good, you guys. I'm in that thing where, you know, when you're watching a show like that with somebody and it's kind of cheating to go ahead without them. I'm watching it with my husband and he went to bed early tonight. So I'm like, what? I can't watch that show. I'm really considering cheating. Don't tell him. 3x over 2. Here's the thing. If I ever do watch ahead of him, I don't mind watching it over again. So I just pretend like I never watched it and just be like, oh, okay, here we go. Let's watch this new episode tonight. And he never knows. Okay, I'm going to write the 3 up a little bit and put it over a 1. Just so that everything looks like a fraction. John writes just the 3 and he makes it kind of float in the middle. I don't like floaty numbers. I think they're dangerous. Okay, let me check and make sure I wrote it right. Yes. Okay, so once again, we notice that there's a binomial there. I'm just going to put parentheses around it right now because I know it's going to be drama. But our first step, as always, is to blow up the denominators. We look for our least common multiple. Okay, it's going to be 14. That one's pretty easy, right? So we're going to multiply everything by 14. Again, I like to put them on the diagonal. It just helps me notice them in a different way. All right, these two cancel to be 7. These two cancel to be 2. And this one, it's just a 1, so I can cross it out, but I'm just going to multiply 3 times 14 so that I don't have to change that. All right, so I'm going to get, ready, 21x plus 16 minus 8x equals, that would be 42. It's a very fancy 2, a frilly 2. All right, what can we do now? We can combine like terms. 21 minus 8 is going to be 13x. I'm going to write it here. And then let's send this 16 packing. Swim that fish. Goodbye. Oh, I wrote that up too high. 13x equals, and this is what, 26? Yes. Oh, and finally John made it come out even. Thank you, John. So much more satisfying. This is x equals 2. Thank heavens. I much prefer a nice clean answer. But wait, I was not smiley facing my answers. Ah, what a flawed human I can be. Okay, well, it was just one, but still. Okay, that concludes our discussion of fractional equations. Now we're ready for just a little delicious tidbit of geometry. And this is a topic called overlapping triangles. Here's the thing about geometry peeps. They just have some conventions that they love. I mean, I guess I'm a geometry person too. I love it. But there's just kind of like a quirky desire to do things a certain way that geometricians are into. And overlapping triangles are just one of these things that we, I guess, are into. The idea here is that we can draw a figure that is essentially 2 triangles. Now, have you ever used, when I was a little kid, there were these things called color forms, and they were kind of like reusable stickers, and they came in sets where you could like make scenes on a cardboard tray. I'm gonna have to look and see if they still exist. But they were like heavy duty plastic stickers that could be reused, and you could use them like there were paper dolls, right? So there would be the doll would be one sticker, and then her clothes would be another sticker, and then she'd have little sticker shoes, little sticker hairdo. Then there'd be like little sticker headbands that you could put on top of her sticker hair. So you could stack them on top of each other, and then you could peel them all apart and put them back again. These are like color form triangles, and I'm still drawing. Because they're essentially 2 triangles stacked on top of each other. See, here's the big one, and here's the little one. So what we want to do is we want to peel off this little one and put it next to the big one. And so it will look like this. Pretend they're like exact. Okay, so this will be A, B, C, right? And then this will be A, D, E. It's the whole big thing. But look, that angle's the same, and then this tells us that this angle is the same. When we do this, we can see, oh, these are similar triangles because they have 2 matching angles, and we know that if we have 2 angles the same, then we know that 3 are the same because they have to add up to 180. And then once we know that they're similar, we know that we can create proportions to solve them. So that's what's nifty and keen about overlapping triangles, is they set up proportional triangles that we can solve. So here's our example. It's example 24.4. It looks like that. We get this little thing up here, and then we get this. That's pretty standard, right? It's just like I had up here, where the top angle is the same, and then these 2 angles are the same. And then that tells us those have to be the same too. So before we even take them apart, we're pretty clear that we've got similar triangles, but what is going to make it even more interesting is when we get this kind of information going on. We get lengths of sides. Whew. All right, we know that we can peel them apart. We know that we can figure out, we can put these numbers on, and hopefully it's going to work out that they are proportional. But we're pretty sure of that because we can already see that the angles are matching up. So let's draw them. Here's the little guy. And that's going to be double angle there, single there. This one is 4. This one is 9. This one is 7. Okay, now let's draw the big boy. And again, I wish I could be so precise that they were exactly the same, but you have to use your imagination. That's not terrible. Okay, this one is the double. This one is the single. This is the one we're not talking about, but we're pretty sure it matches. And let me just do this. Sometimes this helps, is if I remind you that they're both coming from the original picture, right? Here's our little guy, and here's our big guy. That might have just made it worse, but maybe it made it better. Okay, just think of those stickers. Just think of peeling that one off and putting it down there separately. Okay, now we have to figure out how these numbers relate to this. This side is going to be 6 plus 4, right? So this is 10. This along the bottom is y. And look at this. This side is x plus 7. What? That's different, isn't it? But we can do it. We look for our anchor proportions. Okay, we know that these triangles are similar because two angles match, so all three match, and that's what similar triangles do, is they have matching angles but different sides, which clearly they do. We look for our anchor proportion, which is the corresponding side that both has numbers. We set that up. It's 4 over 10. Now let's solve for x first. Let's live dangerously. X relates to this side, so it's going to be 7 over x plus 7. Okay? Anchor proportion, and then side that has the x in it. Make sense? Little triangle, big triangle. All right. Are you intimidated by that? Don't be. Let's just cross multiply. And we'll get 70 equals, and now we have to distribute the 4, right? So it's 4x plus 28. We subtract the 28. And I feel like that's going to be, what is that, 42? Yes, it's 42 equals 4x. Please remember to show the steps just the way that I do, okay? I know you know this by now, but I'm just going to say it again. There's always a method to my madness, and the way that I format the problems matters. Please copy it. Okay, so now we're solving for x. We divide by 4, and we get x equals, and we see we can cut those each in half, 21 over 2, final answer. All right, so we survived this weird x plus 7 thing without too much trauma. I don't know about you, but I feel like it was okay. And now let's solve for y. I'm going to try and squeeze that in down here. And we use our same anchor proportion, 4 over 10 equals 9 over y. I'll take that up to the next page. 4 over 10 equals 9 over y. Cross multiply, and we get 4y equals 90. Divide both sides by 4. And we get, let's see, we can chop this in half, right? We can divide both by 2. That's going to be 45 over 2. And that's as far as she goes, because that is not an even number. Okay, so 45 over 2, that is correct. I didn't even look at my answer last time. And 21 over 2. Yay. Okay, so this overlapping triangles scenario is something that we're going to see again and again and again, and you just peel that top one off and set them side by side, and then usually it's no problem to prove that they are similar triangles, and then we can make proportions out of their side lengths. Lesson 24 is officially completed, my students, and we now can move on to other aspects of our lives. I mean, I'm just moving on to another book, but I think you get to move on. So, congratulations. Enjoy that. I will talk to you all on Thursday or Friday. Thank you for remembering me. Thank you for getting your parent sheets signed. I appreciate it. Okay, goodbye.